Okay. Now I differentiated this, I got this. Now start putting the values. R d theta is already known to me as 20. And I want this to be at that instant when the horse has covered 1/8 the circle, which is actually 1/8 of 360 degree. What is 1/8 of 360 degree? 45 degree. So you want to calculate the change of the speed with respect to time or rate of change of speed at theta equal to 45 degree, and R d theta is always fixed at 20. So answer will be 20 sec square of 45. What is sec square of 45? Root 2 square. So the answer is going to be 40 kilometers per hour. I'm not sure which one will go. Is that okay? Next. Shadow, I'll take one more question. Can I raise this? A lamp is 50 meters above the ground. A lamp is 50 meters above the ground. A ball is dropped from the same height. A ball is dropped from the same height from a point 30 feet away from the light pole. A ball is dropped from the same height but at a distance of 30 feet away from the light pole. So basically, let's say this is the lamp, okay, and the ball is 30 feet away from it and dropped from here. Okay. The ball falls at a rate of 16 t square feet per second. Sorry, 16 t square feet in t seconds. The distance that the ball falls. Okay. So basically the situation is like this. There is a lamp post 50 feet high. Take a ball 50 feet. A lamp is 50 feet above the ground. A ball is dropped from the same height 30 feet away from the light pole. And when it falls, the distance that the ball covers is 16 times t square, where t is the seconds it has fallen down. So let's say in 1 second it will fall 16 meters, like that. How fast is the shadow of the ball moving along the ground? How fast is the shadow of the ball moving along the ground? Half a second after the fall. How fast is the shadow of the ball moving along the ground? Half a second after the fall. Is the idea clear? 16 t square feet it falls.
Shadows form on the ground.
Exactly. So let's say ball is here, then this light will cast a shadow here. Right? So just make a line connecting the lamp and the ball and extend it till it reaches the ground. This will be the shadow of the ball. Correct? So if it falls now furthermore, let's say here, the shadow will be here. So shadow will be trying to chase the ball, so that when the ball hits, the shadow and the ball will hit together. Are you getting it? So the shadow is also moving, the ball is also moving, and at the instant it touches the ground, shadow and ball will be at the same positions.
So lab is 50 meters or 50 feet?
50 feet. So all the dimensions are in feet. If by mistake I have said meters, please correct it. Everything is in feet. Yeah. Sorry? S is the distance fallen down. So at t second it has fallen, let's say this is after t seconds it has fallen 16 t square feet.
that angle theta is changing. Yeah.
Then it is how fast the theta is changing with respect to the height of the scale.
Right.
So it which I relate to d theta by ds because that's the height.
Sir, is it minus 15?
Absolutely correct. See, there are various ways. What is what you are discussing. Alright, let's look at this. First of all, while we are solving such problems, we need to see which two things are connected, which are changing. Of course, the height of the ball and this distance is changing, correct? So first write a relation connecting the height of the ball with this distance. That means strike a relationship between y and x. Correct? How will I do that? Very simple. I can see two similar triangles being formed over here. One is this one, another is this one. These are similar to each other. Correct? So the first relation that I can write between them is x by y. X by y is x plus 30 by 50. Correct?
Or so you can equate the two tangles.
Okay. Yeah, or you can same thing. So from here we get 50x is equal to 50x by x plus 30 is equal to y. Correct? So this is now a function where I am connecting the height of the ball with the displacement of the shadow. Correct? Now we already know that y is going to be at a given time, y is going to be 50 minus 16 t square, because it has fallen 16 t square, total height is 50, so y is going to be 50 minus 16 t square. Correct? Correct? Now let us do one thing. Let us differentiate with respect to t, both sides. What will I get over here? Here I will use the quotient rule along with chain rule. So x plus 30, what is the 50x derivative? 50 dx by dt minus 50x, derivative of this will be dx by dt whole divided by x plus 30 the whole square. Is that okay? And on this side it will be minus 32t. Correct? Now remember, I want to find dx by dt at which instant? At the instant when t is half. Now at the instant t is half, from this equation can I find out what is x?
Yeah.
So let's find it out. So when t is half, 50x by x plus 30 or 30 plus x is equal to 50 minus 16 times half square. Correct? Half square is 1 by 4. So basically this is 4. Okay. How much do I get? 46 is equal to 50x by. Okay. So let's take the term on the other side. So I'll have 4x is equal to 46 into 30. I've skipped some steps. Is that okay? So x is going to be 23 into 15. How much is that? 345. Okay. Now substitute everything over here including t and x. So basically x is 345. So 345 plus 30 will be how much? 375 into 50 into dx by dt is unknown, minus 50 into 345 into dx by dt is unknown, whole divided by 375 square is equal to minus 32 into half. On the numerator we can easily simplify because 50 is a common factor, dx by dt is a common factor, so I will be left with 1500 dx by dt. Okay, and this is minus 16 into 375 square. Okay. Now it looks to be a huge figure, but if you see carefully, 375 is actually 1500 by 4.
Oh yeah.
Correct? 1500 by 4. So this one will become minus 16 into 1500 square by 16 is equal to 1500 dx by dt. So 16 gone, 1500 gone. So this gives you dx by dt is minus 1500 feet per second. So the velocity of the shadow is huge, 1500 feet per second. Is the idea clear how it works? So I'll again repeat whatever I did so far. First I connected the height of the ball with the position of the shadow, correct? Then I struck a relationship like this, substituting my y in terms of t. I differentiated both sides, keeping in my mind that I have to use chain rule there. Then I substituted the instants. The instant was t is half and x was 345 meters, 345 what?
Feet.
Yeah, 345 feet, correct? So that I substituted in this entire differentiated part and I got the unknown which is dx by dt. Make sense? Alright. So one more question we will take and then we'll move on to errors and approximations. Alright, so now consider a situation like this. Okay, so let's say this is my three-dimensional Cartesian coordinate system. There is a bridge like this. Okay. On this bridge, a man is standing. And there is river here. This is river. Okay. There is a boat which is exactly below the man, and the man is on the bridge. So imagine a bridge, man standing just below the man on the river, which is located at 3 meters below the man.
Is the bridge moving with respect to the x-axis?
I'll tell you why I've drawn this. There's a bridge and there's a river flowing below. Okay? The man is standing on the bridge and just below the man 3 meters down is the position of the boat. Okay? Now the boat starts moving at a speed of 5 meters per minute. And the man starts moving along the bridge at a speed of 4 meters per minute. So basically the situation is like this. Initially, wherever I have held this marker, there is a man standing and boat is here. Boat starts moving this way, man starts walking this way. Right? So along the bridge, the man starts walking and perpendicular to the bridge, the boat starts moving. Okay. Now find the change or find the rate of separation. Find the rate of separation of the man and the boat at the instant when time is 4 minutes. Assuming t equal to 0 is when they just started moving. So simultaneously man starts walking on the bridge and boat starts moving perpendicular to the bridge. So after exactly at t equal to 4 minutes, what is the rate of separation of man and the boat? So assuming boat is moving this way, man is moving this way. So man is standing over the bridge and he is looking at the boat. Boat is going this way, man is going this way. So how far are they getting separated? So the change in the separation is what we are concerned.
Let's see if I keep it up. I attach it like this. Still I get yeah, this line
So answer is 164 by root 665 meters per minute. Okay. The problem is most of you are treating it as a physics problem actually. We are into maths class. Okay. So make use of, probably this may help you to solve some of the mechanics problems or vector related problems very quickly. Any question, Vishak? Ashwin? Clear? Alright, so we'll move on now to the concept of errors and approximations and how dy by dx is helping us to find errors and approximate some values. Clear? Done? R.D. Sharma, you'll find very good problems based on that conical vessel and all those things. So please attempt all those problems. There's good amount of problems based on that. Alright. Moving on to errors and approximations. So again, let us consider a function y of x, okay? And let's say due to some unavoidable circumstance, there happened to be an error in x, or let's say there is a change in the value of x by delta x, okay? So we normally call delta x as the absolute error in x. However, there are two more related terms to it which you should be knowing. If I say delta x by x, this is called the relative error. And if you multiply relative error with 100, it becomes percentage error. I know why you are able to answer this so fast, because this was a chapter in physics. Right? So because of this error introduced in x, of course your output will also change. Correct? So if I want to know how has the output changed without calculating my new y altogether again, then we'll use our technique of using dy by dx as an approximation. Now how it works, let me give you the theory first. So let's say, I'll give an example to start with. Let's say there is a cube of h 2 centimeter. So you know the volume of the cube will be how much?
8
centimeter. Correct? Now you later on realize that the cube edge was not 2 centimeter, it was actually 2.0036 centimeter. Then you say, oh my god, I have to calculate again 2.00